In today's video, we're going to talk about physics in IGCSE past papers. And these are exercises that I have extracted from sciences past papers from 2017 to 2021 about physics, and specifically is a motions, force, and energy. So first, we're going to move to question 79. Two blocks of metal, X and Y, hanging from spring balanced as shown. Here is the balance with the X, and this is the balance with the Y. And we can see here is the Newton, or the force acting on two balances. They are equal because here is 3 and here is also 3. We have 3 Newton, 3 Newton. They are the same. So the question is, what does the diagram show about X and Y? They have the same mass and the same volume, but different weight. So there are 3 categories or 3 factors that we have to keep in mind: that the mass, the volume, and weight. So let's take a look at the diagram. We have the same newtons or the same forces acting on the balances. So they are on the same weight. They have the same weight. So the same weight would be the correct answer. This one is different weight. This one, the answer A is different weight, so A is not a correct answer. The same weight, okay, B is maybe a correct answer. C, they have the same weight. D, different, they have the same weight. Okay, so we have 3 answers that have the same weight. So let's talk about the mass. How about the mass? So the equation, the formula that relates the weight and the mass is weight equals gravitational force times mass. By default, the gravitational force of the Earth is 10. So if they have the same weight, then they also have the same mass. So mass would be the same for both of X and Y. The same mass, the different masses. Okay, we cross out the answer D. And the last one is the volume. Let's take a look at the object X and Y. What is the volume of X? The volume of X would be calculated by using the area of the top surface times the height, what we can call h1, and the volume of the block Y would be calculated as the areas of the maybe is it a rectangle or a square, I don't know, but the top surface times the height, or we can say h2. As we can see from the picture, the left and the right, they share the same top surface. So the difference would be the h1, which is shorter than the h2. So they have the different volumes. So same mass, same weight, but different volumes. Answer B is the correct answer. Let's move to the next problem, 31. The sun is an important energy resource. Which energy source powers the sun? Chemical. Is this possible? No. Chemical is not a source to power the sun. Geothermal is not, because geothermal comes from the inside of the earth. How about the nuclear fission? Nuclear fission, which means the fission here, which is the separation. It is not the source to power the sun either. And the last one is nuclear fusion. So what is the fusion here? The fusion is the combination of 2 nuclei to become one single atom, like hydrogen plus hydrogen equals helium and energy. And the energy come from the sun would come from this equation here. So the fusion, nuclear fusion would be the correct answer for this problem. Okay, because inside the sun we have the fusion, that two hydrogen nuclei combine together to become a helium atom. So the next question is 29. An astronaut travels from Earth to the moon. The gravitational field strength on the moon is less than that on Earth. Of course. How do the mass and weight of the astronaut on the moon compare with his mass and weight on the Earth? We have the table to compare two different values, which is mass and weight. So when we talk about mass, we think about the matters that make up that subject or that make up the astronaut. So wherever he is, maybe he is on the moon, on the Mars, or on the Earth, the matters make him up would be the same. So the mass of the astronaut would be the same whether he is on Earth or on Mars or on the moon. So the same mass, we have the answer C and D. So let's talk about the weight. As we have talked before, the weight would equals gravitational force times the mass. We have the same mass, but does we have the same gravitational force? Let's take a look at the Earth and the moon. Basically, the moon is just a small sphere, and the Earth is a big circle, is a big ball. So the gravitational force on the Earth would be much larger than the gravitational force on the moon. So that would be that would result in the weight on the Earth would be greater than the weight on the moon. We have the answer C, less than on Earth, would be the correct answer. So we choose the answer C.